Alright, welcome to 3.2 logarithmic functions. Our essential questions are: how are exponential and logarithmic functions related, and how can we model a real-life situation with this equation? So, the definition: for when x is greater than 0 and b is greater than 0 but also doesn't equal -1 or doesn't equal +1, y equals log sub b x. This is equivalent to b to the y equals x. Write down this part there. So you want to write down your conversion. You want to write down your conversion. So your function f of x equals log sub bx is your logarithmic function with base b. So we're going to do a couple examples of writing the equivalent, so make sure you have it written down. So to start with, you have 3 equals log 7x. So you want to think, what does this mean? So you have b, which is your 7, y is 3, equals x. So now you have b to the 2 equals 25. So try the last one on your own. Pause the video and try the last one on your own. You should have gotten 4 to the y equals 26. Now we're going to go the other way. So in this case, we're going to look at our exponent and go back to the log. So your y is your power, so you have 5 equals your log. B, in this case, is 2. And your x goes so let's look at the next one. Same idea, you want to look for your y, which is going to be your 3 equals log. Find your b, which in this case is just b, and your x is 27. So try the last one on your own, and then we'll go over it. So you should have gotten y equals log e 33. So we were just doing conversions before. Now we're going to evaluate these problems. So you have log 10 of 100. If you think about your conversion, that means you have 10 to the y equals 100. So that means y would have to be what? So you want to think, 10 to what power gives me 100? That would be 2. So your answer, log sub 10, 100 equals 2. The second one, this would convert to 5 to the y equals 1 over 125. So what power of 5 gives you 1 over 125? You know it has to be a negative because you have 1 over it. So you want to think 5 to the what gives you 125. So you should get -3, or 5 to the third gives you 125. So 5 to the -3 would give you 1 over 125. So that means you have log 5, 125 equals -3. Let's try this one. If we were to convert this, So you have to think, what gives you the 7th root of 3? What would x have to be? If you have 3 to the 1 7th, you have 7th root of 3. So now you have So there's some basic logarithmic properties involving 1. So if you have log sub b, that's going to be 1. Because 1 is the exponent to which b, so it must be b to the 1 is just going to be b. Log b1 equals 0, because 0 is the exponent to b, so b to the 0 is going to be 1. So let's look at a couple of these examples. So if we think about our rule, since I have 9 and 9, it's going to equal 1. And for the next one, if you think about your rule, because you have a 1, it's going to be 0. These are just because of the rules. So the inverse property of logs. For b greater than 0 and b does not equal 1, if I have log b to the x, it's going to equal x. Or if I have b raised to the log bx, it's going to also equal x. So let's look at a couple examples of this. Write down these rules. You also wanted to write down your log properties. Alright, so based on our rule from before, it's going to be 8. And again, based on our rule from before, it's going to be 17. This is the inverse rule. So, make sure you complete the questions below and watch the next video. Next time we're going to talk about graphing logs.